Hello students, welcome to my next online class. So here I am with a new chapter, that is current electricity, and I hope you have written all the exercise questions in your exercise book of last chapter sound. If you haven't completed yet, do complete it very soon, right? So make your copy up to date. So without wasting any time, let's start our today's class, current electricity. So what is electric current? In class 9 we have learned the rate of flow of charge is said to be as electric current. That means whenever there is flow of charge, there is a production of current. Like wherever there is a vibration, there is a production of sound. Similarly, wherever there is a flow of charge, there is production of electric current. Now you see, the rate of flow of charge per unit time is considered to be as electric current. Now when I ask what is 1 ampere, that means ampere is the unit of current. Now when I say state 1 ampere, that means a current is said to be 1 ampere when 1 coulomb of charge passes through a cross section of a conductor in 1 second, right? When time is 1 second and 1 coulomb is the unit of charge. So when 1 coulomb of charge is passing through 1 second through a cross sectional area of a conductor, then we say that 1 ampere current has been passed, right? So this was 1 ampere, that is equals to 1 ampere. Okay, now you see there is a cross sectional area of a conductor. Now that cross sectional area of a conductor might have n number of electrons. So how many electrons is being passed? That is, what is the total charge contained in that conductor? Then we can say the total charge contained in the conductor is given by Q equals to Ne, where N is the number of electrons and E is the charge of a single electron. That one we know, that value is E equals to 1.6 into 10 to the power minus 19 coulomb, right? Now as it is an electron, so we can place a negative sign, or just for the numericals you can consider the positive quantity only, right? So charge of an electron is minus 1.6 into 10 to the power minus 19 coulomb. Okay, so what is the total current passing through that conductor? That is I equals to Q by T. In place of Q we are substituting this Ne by T. So Q equals to Ne. This is also called quantization of charge, right? I repeat, quantization of charge. In class 9 we have learned total charge enclosed in a conductor is equals to integral multiple of basic unit of charge. Integral multiple of basic unit of charge means, you see, if I consider there are 5 pencils, right? The cost of 1 pencil is 3 rupees. So definitely the cost of 5 pencil will be 3 into 5, that is 15 rupees. Now when I say the number of pencil is infinite, infinite means that means we cannot count here. Let us consider the n number of pencils are there. Then what will be the total price? That is 3n, right? Similarly, you see electrons, charge is fixed. Now here in this case number is not fixed. So therefore we say that total charge enclosed in that conductor is equals to Q equals to Ne. This is also called quantization of charge. Okay, do not forget, they might ask separately what is quantization of charge. So quantization of charge means here total charge enclosed in a body is equals to integral multiple of basic unit of charge. That means Q equals to Ne. Okay, also what do you mean by conservation of charge? Charges cannot be created nor be destroyed. It gets transferred from one body to another, right? Charges get transferred here. Like you see, energy is changing form from one form to another. Similarly, here charges is getting transferred from one body to another. But you see, total number of charges remains same. For example, there is a glass rod, and glass rod, when you rub in your hair, the glass rod develops positive charge. Similarly, your hair develops negative charge. If I consider there are 5 positive charges has been developed in your glass rod, what does this mean? This means that 5 electrons from the conductor has moved to your hair. That means equal and opposite charge got transferred, right? So this was conservation of charge and this is quantization of charge. Okay, now we will come across the units. There are different subunits and multiple units of current. Like subunits, when I say that is 1 milliampere equals to 10 to the power minus 3 ampere. 1 microampere equals to 10 to the power minus 6 ampere. Okay, so these are the values which we will be using in numericals. Now when I am talking about electric current, current flows from higher potential to lower potential always. When I say current flows, that means charges flows from a higher potential to lower potential. Now if both the potentials are same, suppose A and B, two potentials are there, two terminals are there, so current is moving from A to B. This indicates that terminal A is at higher potential and terminal B is at lower potential. Now when we say that higher potential and lower potential, you see, if any body has excess of electrons in it, then we say it is at lower potential. Now any body which has excess of or deficiency of electrons, that is excess of positive ions or positive charge, will consider to be as higher potential, right? So charges flows from higher potential to lower potential, and its direction is opposite to the flow of electrons, right? So higher potential to lower potential, when charges is flowing, its direction is opposite to the flow of electrons. Therefore we say that if both the points, both the bodies are having at same potential, will there will be any flow of current? No, there won't be any flow of current, because we know it is just analogous to heat. If both the bodies are at same temperature, heat will not flow. Similarly, if both the bodies are at different potential, then only the current will flow from a body having higher potential to a body having lower potential, right? So this was the concept of potential. So what is potential actually? So it is an electrical state of a conductor which determines the flow of charge. Okay, I repeat, potential is an electrical state of a conductor which determines the flow of charge from one body to the another. Okay, now in other case, if I say what is potential difference, then potential difference, you see, there are two terminals are there. Suppose from one terminal to other terminal the current is flowing. Just now I said, you see, the current flows from a potential having higher potential to a body having lower potential. That means there is a difference in potential between the two terminals. So that potential difference is defined as the amount of work done in transferring a unit positive charge from one point to the other. Or you can say electric potential or potential difference is defined as the amount of work done in bringing a unit positive charge from infinity to a given point, right? So this was potential difference. The notes which I have written in board, this one you need to write in your exercise book. So on the screen you can see I have written the definition of potential. It is the electrical state of conductors which determines the direction of flow of charge when two conductors are connected by a metallic wire. So when two conductors are connected by a metallic wire, provided that one conductor is at having higher potential and one conductor is at lower potential, so current will flow from a body having higher potential to a body having lower potential, and direction of electric current is opposite to the flow of electrons, right? Here is the deficient of electrons and excess of electrons, and here it is deficient of electrons. So current is flowing from higher to lower. Now when I say, you see, these two substances or two body are connected with a metallic wire. Now if I need to find the potential at a given point, so where there is difference in potential, in between the way there are many potentials, there are many points between two bodies. Now if we need to find the potential at a given point, what is the potential of a body at this resistance, and that resistance is between many other resistances, right? So in that case we have to find the potential at a given point. So potential at a given point is defined as the work done in bringing a unit positive charge from infinity to that point. That means at that point what will be the potential is here, the amount of work done in bringing a unit positive charge from infinity to a given point. Okay, where you want to find the potential. So that is defined as potential at a given point, whose formula is W equals to QB, or potential, electric potential equals to W by Q. Now SI unit of potential is here volt. Now if I say state 1 volt, then you say when 1 joule of work is done in transferring 1 coulomb of charge from infinity to a given point, the potential is said to be as 1 volt, right? So these are the definitions. Few definitions you have to analyze and you have to write by yourself. Now, when I say this is one body, now let us remove these charges. Okay, so this is terminal A and this is terminal B. Okay, we don't say this is higher or lower potential, and the current of flow of current is also undetermined here. Now when I say there are two bodies, that is A and B. Okay, so when I say A and B here, so what is the potential difference between A and B? Now if we need to find here potential difference between two terminals here, this is one terminal and this is the other terminal. One terminal is A and another terminal is B. Now if we need to find the potential difference between these two terminals, then we have to find the work done. That means amount of work done in transferring a unit positive charge from one terminal to another terminal. Okay, this is the potential difference. So when two terminals we know and we need to find the potential difference here, so we have to calculate the work done in transferring a unit positive charge from one terminal to another. So this is the concept of potential difference. Now just now we have seen the formula V was equals to W by Q, right? So V equals to W by Q. So W means here work done and Q is the charge. When 1 joule of energy is being compensated on transferring a 1 coulomb of charge, that means 1 joule of work is being done to transfer a 1 coulomb of charge from one terminal to another, and we say to be as potential difference as to be as 1 volt. Okay, so this was in case of potential difference, and that is the potential at a given point. So opposition to the flow of electric current is considered to be as a resistance. So whenever any electric current tries to pass through any conductor, so there is an opposition. That means the current cannot pass freely through that conductor. So we say that there is a resistance in that conductor. Okay. So this resistance, now question arises how this resistance produced or how this resistance is created in any conductor. Okay. Let's do it with an example. I have considered here two metal wires. Okay. This metal wire, it is in unbiased condition. That means I have not connected any battery here. Any source, external source, when I have not connected here, it is in unbiased condition, and electrons and positive ions, they move randomly in all directions. That means they are in Brownian motion, right? So they are moving here and there. They don't have a fixed direction. But as soon as when I connect to a battery or an external source, we see that electrons gets drifted towards the positive terminal. That means electrons gets passed towards the positive terminal. That is called drift, right? So electrons get drifted towards the positive terminals and positive ions get drifted towards the negative terminal. In this process, what happens when electrons tries to move towards the positive terminal, it gets collide with each other. That means electrons gets collide with electrons, and these electrons gets collide with the positive ions. So on collision, the speed of electrons decreases. So due to this decrease in speed in electrons, there is a decrease in energy, that is the kinetic energy of that electrons, right? This generates the resistance. So therefore there is an obstruction to the flow of electrons towards the positive terminal, and this creates a resistance in that conductor. Okay, so due to collision of electrons with electrons on obstruction to the positive ions, when they collide with the positive ions, their speed gets reduced, and due to decrease in speed, their kinetic energy gets reduced, and therefore there is obstruction to the flow of charge, that means electric current. Okay, therefore this is how this resistance is produced. The SI unit of resistance is ohm. OHM we say ohm, or the SI unit is written just like as this, that is this is also considered to be as ohm. So there are few factors upon which this resistance depends. You see, the resistance of any conductor depends upon upon the length. That means resistance is directly proportional to length. If the length of the conductor is more, then the resistance will be more. Resistance is inversely proportional to area of cross section. That means if the wire is very thin, that means the resistance will be more. Therefore, wire, if it is very thick, then resistance will be less. Therefore, for the transmission lines which we take from the nearby electric poles, we take a thick wire. Thick wire means here area of cross section is more, therefore resistance will be less. Therefore, the electric current will be more. We will get the more electric current, right? So that means R is inversely proportional to A. A is the area of cross section and L is the length of the conductor. This resistance also it depends upon the temperature, right? If more is the temperature, that means the resistance of wire gets increased. Therefore, similarly, if there is a decrease in temperature, then resistance will decrease. This concept has given a rise for the superconductors. Okay, so superconductor or the superconductivity is a condition at which the resistance of a substance or the resistance of that conductor is said to be nearly to be as zero. So when the resistance is said to be as zero, then the electrical conductivity will definitely it will increase. So it forms a superconductor. Okay, so you see, just that's for giving different knowledge. So that will be we will have in next class, or sometimes they ask in these board exams also. So what are superconductors? So generally the superconductors are used in these computers and there are many applications of here. That one will come on later on, right? So resistance depends upon length, resistance depends upon area of cross section, resistance depends upon temperature. It also depends upon temperature, and also it depends upon the nature of the material. That means it depends upon nature of material. Okay, now including these two, R this can be written as L by A, right? So R this can be written as rho L by A, where rho is called resistivity. Okay, so resistivity of any wire is equals to a resistance when the length of a wire is 1 meter and area of cross section is 1 meter square. Okay, so this is how we define the resistivity. So this resistivity depends upon the nature of the conductor, or you see, it does not depend upon the shape and size of the wire. Okay, so this resistivity is independent to the shape and size of the wire. So these are the factors affecting the resistance of the wire. That is first nature of the material of the conductor. Okay, same, next we have length of the wire and we have area of cross section, that means thickness of the wire. So this resistivity note also you will be writing in your copy, and therefore the resistance also depends upon the temperature. Increase in temperature, that is rise in temperature, increases the electrical resistance. So this is the formula, R equals to rho L by A, or rho equals to RA by L, just we have cross multiplied, right? So you see, rho equals to R, that means resistivity of a wire equals to resistance when when the length of a conductor is 1 meter and area of cross section is 1 meter square, and the unit of resistivity is ohm meter. So this differences you need to write in your exercise book, that is resistance and resistivity. What is the main difference between resistance and resistivity? Resistance is the obstruction offered to the flow of current by the material of a conductor, and resistivity is the property of the conductor due to which it offers resistance to the flow of electric current passing through it. It is measured by the potential difference required across the ends of a conductor to the flow of 1 ampere current through it, and resistivity, it is measured by the resistance offered by 1 meter of length of a wire at a material of area of cross section 1 meter square. Okay, so this differences you will be going through. So you see, units are also changed. As a unit of resistivity is ohm meter, whereas resistance is only ohm. Conductivity, you see, reciprocal of resistivity is said to be as conductivity. It is abbreviated by the symbol, you see, sigma. This is the symbol of conductivity here. It is also called sigma. Its SI unit is per ohm per meter, or it is called Siemen meter, right? Do not forget this one. So this is very important, right? Sometimes they come, what is conductivity and what is resistivity, what is conductance. So more or less they are all same terms. So for this video only this much. In the next class we will going through the Ohm's law, that is ohmic substances and non-ohmic substances. Till then you will be writing this note in your exercise book, and you prepare the previous exercise questions also, right? Note down in your exercise book. So till then, thank you.